Hello everyone. Today I would like to talk about how to design a continuous beam structure for a reinforced concrete building. For this purpose, we have an assignment. First of all, I want to show you the model, how the model looks like. So I'll just share the screen. Okay, now this is the assignment. The requirements are to shear and bending moment diagrams using a coefficient method. Later on, design the beams for flexure, shear, and serviceability, and then designing the columns for bending and shear, later checking for serviceability. All the data are given over here, and all the other related data can be assumed or can be found from the codes that related to the concrete design. This is the model of the building, which is one-story building, consists of 3 panels in the X direction and 2 panels in the Y direction. The dimensions are given for each student, depends on the data for each student separately. So, and later on we solved an example. For example, each student shall submit a sample of the assignment like that. After the consulting with other professors to deal with the function of residential building, taking the life load into consideration as 1.93 kilopascal for residential building. The building loading over the building can be distributed like this shape. This is the shape of the building over the plan. This is the top view. We are going to design B1, B2, and B3 for the grid line B. This is the same concept for grid line A and C. The only difference between grid line A and B is the grid line A, as can be here, is the L-shaped beams, and grid line B, this is B, which is T-shaped beams. For this example, we will design the T-shaped beams. The tributary area of the beams is the same. The loading of the beams is the same of the tributary areas of the beam, all the beams. If you take a look at the area of this shape is trapezoidal, and the loading, same thing, trapezoidal. This dimension is 4.5 divided by 2, which is half of it, and this is the longest span, 6 meters. So subtracting 6 meters by 4.5 remains 1.5 at the middle. So the trapezoidal center would be 1.5 above in both sides of the triangles. This is correct for the other side, for other beams, which is B2, but it's not correct for B3. B3, B2, it's a cantilever, so the loading of it is the same shape of the tributary area, which is 2 triangles. Actually, if we consider one triangle and multiplying by 2, because both spans are the same in length. After taking the consideration of the loading with trapezoidal shape, you will find out the value of each parameter. Let's say W1, W2, W3, until the end. For example, W1 is equal to 7.92, which is total dead load, times 2.25, which is half of this 4.5, times 2, because we have 2 sides. So it's 35.64, and all the others, same procedure. In addition to the self-weight of the beam, self-weight of the beam can be found from the calculation, which is 4.53 kilonewton per meter. After analyzing that, we will go to the next step, which is transforming the trapezoidal loading to the rectangular loading, because as we use the coefficient method, we cannot use non-uniform loading over the beams. So transforming the beams, the loadings, simply we can change all the non-uniform loading to a single point load, then distributing over the beams. For example, now we have here 35.64, which is this point. So this one times this part, which is 2.25 times 0.5 would be a point load. dividing by total length, which is 2.25, but we're not gonna do this alone. We'll sum up all of the loadings of that beam. For example, we have one here, resultant force here, another one here, and the third one would be here. Sum up all the loadings, divide by the length, which is 6 meters. You will get a value, something looks like that. Then drawing the moment diagram for dead load, and same thing, moment diagram for the live load, then sum up both moments for dead load and live load. Same concept for shear diagram. Once the shear diagram end up for both dead load and live loads, we'll go through the next step, which is the design and finding the dimension and the reinforcement. This is a short observation of the design for using coefficient method. Hope you benefit from that, and have a nice time. Bye bye.